The launch of the James Webb Space Telescope on Christmas Day 2021 marked a significant change in cosmology. With its remarkably keen, high-resolution infrared eyes, this cutting-edge telescope has transformed our knowledge of the universe since it was deployed. By looking back into the early universe, James Webb has given us clear, immaculate, and exquisite insights into how stars, galaxies, and planetary systems, including our own solar system, formed. James Webb's abilities, however, have exceeded expectations. Scientists expected to see young galaxies, but the telescope revealed a record amount of them, some of which are counterintuitive. Webb's discovery of these early galaxies casts doubt on the viability of accepted hypotheses in the universe's beginnings, challenging our current cosmological models. Our expectations are put to the test as we go farther into the far-off cosmos. As we travel through time, we expect to see a slow decline in the number of massive galaxies. But James Webb's findings show a different picture, with a multitude of surprising galaxies, some of which are even older than the universe. We are essentially questioning the universe about its early years and how it changed to become what it is now by studying these old galaxies. Because of its spectroscopic capabilities, the James Webb Space Telescope enables us to test our current theories of the cosmos, expanding our knowledge and maybe changing how we see cosmic history. James Webb's importance goes beyond its capacity to photograph breathtaking celestial occurrences. It is rewriting the story of our cosmic beginnings. By revealing galaxies that are billions of years old, initiatives like Webb's, SEERS, and the Cosmic Evolution Early Release Science Survey are appending our assumptions and broadening our understanding of the universe. Maisie's galaxy, which bears the name of researcher Stephen Finkelstein's daughter, is one noteworthy discovery. This galaxy, which is 13 billion years old, surprised everyone with its color and brilliance. Its existence shows that our cosmos is far richer and more complicated than previously thought, challenging our basic understanding of the early universe. Using infrared wavelengths, the James Webb Space Telescope has a unique ability to identify very distant galaxies. For observing galaxies that have greatly receded as a result of the universe's expansion, this wavelength is essential. Although some of these distant galaxies have previously been spotted by the Hubble Space Telescope, which primarily operates in the optical light wavelength, there had been little observation of them. This restriction resulted from a phenomenon known as redshift, which causes galaxies' light to shift towards longer, redder wavelengths as they get farther away from us. Because of this, they become less visible in optical light and must be observed in the infrared. Hubble's telescope struggled to pick up even a handful of these far-off galaxies, but the James Webb Space Telescope quickly outperformed these efforts. Days after it began its scientific activities, it discovered a large number of galaxies that were considerably more distant than anyone had ever imagined. When scientists talk about these galaxies, they usually talk about how old they are, not how far away they are. This method was used because conventional distance measurements are made more difficult by the expanding universe. Take Maisie's galaxy, for example, which is said to be 13 billion years old. Even though it took 13 billion years for the light from this galaxy to reach us, the universe is still expanding, so it is currently considerably farther away than its age would imply. By examining spectral lines, the near-infrared spectrograph on the James Webb Telescope helps determine ages more accurately. Astronomers can use these lines to calculate the galaxy's true redshift, which is a gauge of its age and distance. It was one among the 4 oldest galaxies proven by spectroscopy after a subsequent spectroscopic investigation showed a redshift of 11.4 after being first predicted to have a redshift of 11.8 based on photometric data. These findings contradicted past cosmological theories, indicating that galactic creation most likely began earlier and advanced more quickly than previously believed. The discovery of galaxies only tens of millions of years after the Big Bang suggests that huge galaxies formed sooner than previously thought. This has significant ramifications for our comprehension of dark matter and how early cosmic structures were formed. These results highlight the need for more research and improvement, even though they haven't disproved popular cosmological models. Our view of cosmic development has changed as a result of James Webb's findings, which have revealed a universe that is far richer and more complex than previously thought. Scientists expect more discoveries that will expand our understanding of the universe's beginnings and development, as they continue to explore the cosmos with this groundbreaking telescope. Because the majority of a galaxy's luminosity comes from its individual stars, the brightness of a galaxy is closely related to its mass. Astronomers can approximate the total mass of a galaxy by assuming a particular average mass and brightness for each individual star. However, scientists have come to the conclusion that galaxies could not have acquired such vast sizes in the relatively short time since the universe's genesis based on a large portion of their modeling to date. Jorge Moreno, a Pomona College associate professor of astronomy, compared this disparity to running into a teenager in a kindergarten class. Up until recently, the majority of galaxies were divided into two primary groups: ellipticals, which resemble smooth, spherical masses of light, and spirals, which have disk-like structures with spiral arms of gas and dust. Astronomers had previously believed, however, that early universe galaxies would not have the organized classification found in contemporary galaxies. These presumptions are called into question by the James Webb Space Telescope's observations. The brightness and structure of some of the early galaxies seen are strikingly similar to those seen in the local universe. Since the existence of such huge galaxies in the early cosmos defies earlier predictions, astrophysicists are also questioning the age of the universe itself in light of this surprising amount of structure and luminosity. According to one researcher, the universe might be about twice as ancient as previously thought, with an estimated age of 26.7 billion years. There is still disagreement among experts on this theory, though. Unaccounted processes influencing galaxy formation or the role of dark matter in the early cosmos could be the cause of the disparity between current models and observational data. Scientists knew that the early universe was very different from the cosmos we see now, even before the James Webb Space Telescope was built. Galaxies in this era were primarily made of hydrogen and helium, influenced by dark matter, and supported enormous, short-lived stars. The early universe's different chemical makeup from the modern universe is highlighted by the lack of heavy components. In addition, the older stars, referred to as population 3 stars, were very different from their contemporary counterparts. Because of their elemental makeup, which lacked heavier elements, these primordial stars were bigger, hotter, and bluer, and they emitted more ionizing radiation. Astronomers believe that the James Webb Space Telescope may offer the means to discover these elusive celestial objects, providing crucial insights into the early years of the universe, even though no population 3 stars have been directly detected. The James Webb Space Telescope was essentially created to transform our knowledge of the early universe. By providing a window into the universe's remote past and illuminating the basic mechanisms that influenced its formation, the intriguing evidence it has acquired advances our quest to discover the mysterious first stars of the cosmos. Although the topic of billion-year-old history may seem abstract at first, it is crucial to comprehending the universe as we currently understand it. With its unmatched powers, the James Webb Space Telescope is revealing previously hidden facets of the universe and offering previously unheard-of insights. Understanding the beginnings and development of celestial bodies, such as our own Milky Way galaxy, requires this greater comprehension. It is impossible to directly observe objects like galaxies over their lifetimes because astronomy works on such large timescales. Astronomers must examine distant and ancient counterparts, like newborn images of the Milky Way, in order to investigate the evolution of galaxies. This work is essential to understanding the complex mechanisms that underlie galaxy creation and evolution, providing important new information about our cosmic beginnings. Furthermore, the search for extraterrestrial life has taken an interesting turn when NASA revealed that 17 exoplanets it has found may have subterranean oceans hidden beneath massive ice sheets. These worlds, which resemble Jupiter's frozen moons, offer encouraging opportunities for the detection of biosignatures, which are chemical indicators of life. Subsurface oceans may be maintained by internal heating processes driven by radioactive decay and tidal forces from host stars, despite their cold surface temperatures and lower density than Earth. Similar to ice volcanoes, cryovolcanic eruptions may also be a sign of geological activity and possible life habitats. In a stunning discovery, researchers have unraveled the dynamics of Mars' atmosphere, exposing a brief occurrence in which some of its atmosphere was momentarily swept into space. NASA's Mars Atmosphere and Volatile Evolution Orbiter witnessed this occurrence, which highlights the dynamic interaction between Mars and the solar wind and provides previously unheard-of insights into how the Martian atmosphere reacts to solar activity. These findings have ramifications that go well beyond simple scientific interest. They help us comprehend planetary systems, habitability, and the larger forces producing our cosmos. Every new discovery we make as we extend our understanding of the universe pushes the limits of human knowledge, challenges our assumptions, and helps us solve the riddles of life. An important development in the history of Martian atmospheric dynamics is the recent unusual episode that was seen at Mars thanks to the MAVEN satellite. This unusual event, the first of its sort in almost 10 years of MAVEN's mission, occurred as a rapidly moving solar wind zone passed its slower counterpart, essentially sweeping away Martian atmospheric particles. On December 25, 2022, the resulting sparse zone arrived at Mars, giving scientists a rare chance to see the expansion of the planet's atmosphere, similar to what it may have done if it were orbiting a less chaotic star. According to MAVEN project head Jasper Hollers, this unforeseen incident is a Christmas present from nature, making it the ideal scientific test. It provides important insights into the history of Mars' atmosphere by allowing scientists to examine the effects of intense solar outbursts and their absence. Additionally, these results have wider ramifications for comprehending exoplanets that resemble Earth and their interactions with their parent stars, offering vital information to improve models of planetary atmospheres outside of our solar system. By providing a thorough explanation of the observable occurrences, Hollers and his colleagues' thorough investigation illuminates the fundamental physics driving Mars' atmospheric dynamics. MAVEN team member Skylar Shaver highlighted the importance of understanding the physics and figuring out the complex dynamics at work. Like a jiggling plate of jello settling after a disruption, Mars' atmosphere slowly returned to its initial state after the diminished solar wind storm passed. Even while similar occurrences have happened before, the existence of orbiting spacecraft like MAVEN offers previously unheard-of chances to thoroughly examine such phenomena, enhancing our knowledge of planetary atmospheres and how they react to solar activity. This brief occurrence also provides intriguing insights into Mars' early history, indicating that severe solar flares of this kind were frequent in the planet's early years. These discoveries highlight how Mars' atmosphere is dynamic and have significant ramifications for the planet's geological past and habitability. As solar activity nears its peak, scientists predict that several such occurrences may take place in the years to come. We can anticipate more discoveries regarding the complexities of Martian atmospheric dynamics and their implications for planetary evolution as scientists continue to track and examine data from MAVEN and other missions. In other news, after a string of failures with one of its gyroscopes, NASA has reported that the problems ailing the Hubble Space Telescope have been successfully resolved. Notwithstanding these difficulties, the venerable telescope, which has been studying the universe for more than 30 years, remains an essential instrument in our effort to solve its secrets. By starting up again, Hubble confirms its long-standing reputation as a pillar of astronomical study, enhancing the work of new observatories and guaranteeing more discoveries in the field of deep space exploration.